All rope access rescue scenarios are constructed by building upon the basic maneuvers each technician is trained to perform, and applying them in sequence to access and move the casualty to safety. In this scenario, 2 rescuers make use of hauling and lowering systems to move casualties horizontally. They will combine the basic climb-in maneuvers with building the hauling and lowering systems, then use teamwork to transfer the casualty to a new position. A Petzl rigging plate is used to keep attachment points clear and organized. The rescuers ascend to a position above the starting and destination points. The technicians find a comfortable working position and begin to build the hauling systems. Independent anchors are built for each of the hauling systems working and safety ropes. Petzl shunts are used as the rope capture device for the backup safety ropes. Petzl IDs are rigged as the rope capture device for the hauling systems. This will also provide for braking control when the systems are converted to lowering. The technicians use 2 additional sets of ropes for this scenario. The safety rope is rigged through the shunt and a stopper knot tied in the free end. The hauling line is rigged in the ID and the slack pulled through. A stopper knot is tied in the free end of the haul rope. Care must be taken to ensure that the 2 systems are well organized. and that the ropes are kept separate and are not fouled. The technicians begin to assemble their mechanical advantage systems. Typically, a 3-to-1 mechanical advantage with redirects through a pulley or a carabiner. An inverted shunt with a pulley is attached to the load side of the haul rope. The control rope is passed through the pulley. Each technician uses the equipment normally carried on his harness to build a system. The technician on the right is using the Petzl Basic as a rope grab attached to the traveling pulley. The free end of the control rope is then redirected through a second pulley attached to the carabiner, supporting the ID. This will allow the technician to pull downward on the haul control rope to lift the load. The slack is worked out of each system, and the components are checked for proper action. A handled ascender with a foot loop is attached to the control end of the working line below the redirect. The technician will use his leg muscles to lift the load. In this manner, the casualty will be lifted on the first system and supported while the system is converted, then lowered out until supported by the second system, and then raised or lowered as the circumstances of the rescue dictate. The technician locks off the ID and converts the first system to lowering by removing the redirects and hauling system components. The second technician uses his haul system to tension the lines, helping to maintain the height gained by the initial lift. The casualty or load is then lowered onto the second system using the ID to control the descent rate. The team will alternate lifting and lowering to maximize height when necessary for clearing an obstacle, or the casualty can simply be lowered out until the load is supported by the second system. A suitable method of paying out the backup rope should be used. That prevents the possibility of shock loading the system. The load must not be allowed to fetch up on the shunt, or the system may have to be converted back to haul to disengage the unit. This technique can be repeated and varied in the same manner as a rope-to-rope transfer, to maneuver the casualty or load through multiple obstacles, and then raise or lower to the final safe location.